Okay, so Gurjit, would you mind just elaborating a little bit more as to why listening with two ears is important?
You know, it's important for almost all of the auditory tasks that we engage in.
Mm-hmm.
It's important for speech understanding in noise. It's important for localization abilities, listening in complex listening environments of the sort that are difficult for people with hearing impairment. Listening with two ears takes advantage of a number of mechanisms that help us to better understand speech. One of my favorites that we're studying these days is looking at the effect of listening effort and how it's minimized once you are listening with two ears.
With regards to Phonak's binaural voice stream technology within the hearing instruments, how do we help, or how do we use binaural voice stream technology and to somehow mimic or to create these effects?
Binaural voice stream is really closely coupled with the sensors that we have for classifying the environment. And so it's critically dependent on finding an ear where there's a better signal-to-noise ratio. Mm-hmm. And wherever there is that better signal-to-noise ratio, a copy is then streamed to the other ear where there's a poor signal-to-noise ratio. Okay. This is a facet of listening for normal hearing, and it's what we do best in terms of unmasking of speech. And this is what we're trying to mimic and enhance with binaural voice stream technology.
Okay.
But there's other effects as well, but I'm sure we'll get into that in a second.
In your insight that you wrote, Listening with Two Ears Instead of One, you explain how listening improves with full audio streaming between hearing instruments. Could you just elaborate a bit further as to how that happens?
Yeah, sure, no problem. The ability to stream a signal from one ear to another really represents a technological leap. And that's because when you're in a complex listening environment, there's often a better signal-to-noise ratio at one ear relative to the other. Mm-hmm. Because of our classifier, we're able to make that detection, and then we send where the signal is better and send it to the other ear. And this is really important for two reasons. The first reason is that you'll experience a summation, because you have the same signal in both ears, and that results in an increased percept of that target signal. Mm-hmm. This is called binaural loudness summation. The other effect is binaural redundancy. And what I mean by that is the ear has multiple opportunities to capture the cues that are available in a signal. So if you have a different hearing loss between the ears, you might get some of the cues with one ear and other cues with the other ear.
In conclusion, could you just sum up for me in your own way the advantages of binaural voice stream technology?
You know, it's really interesting because for over 50 years we've been conducting research in hearing looking at basic psychoacoustic phenomena. And we've understood a lot about the ear, but up till now we really haven't known how to apply much of that finding, much of this research to technology. But now that we have the capability to wirelessly stream a full audio signal from one ear to another, we can start to take advantage of all that we've learned over the past 50 years. But the primary benefit is that we are assessing where there's a better signal-to-noise ratio at one ear and sending that signal to the other ear. This takes advantage of binaural loudness summation, hearing a signal with both ears, and having that increased perceptive loudness. Mm-hmm. If you've ever talked on the cell phone and you've listened with one ear and then listened with that same cell phone connected to both ears, it's so much easier, and that's the type of benefit that you experience with binaural voice stream technology.